In this lesson, we are going to talk about the average value of a function. And so we're going to kind of connect this to a calc, an integral kind of a thing. And just to kind of refresh, the idea of an average is the sum divided by some sort of a number. So if you have 5 items, you're going to add those 5 items together and divide by 5. So in calc, we're going to do the same thing, but our sum is going to be the integral because that represents a limit basically of a summation of a whole bunch of different values. You're getting an area under a curve. So here's kind of usually what the formula looks like, but I like to try to compare it to what I'm familiar with. So I'm going to do the integral divided by a number, right? And that number is going to be, well, if I'm going from 5 to 10, then I'm going to kind of find the difference between those two, and I'm going to take that sum and divide it by 5. So let's do a couple examples related to that. So we're going to find the average value of the following functions on the given interval. So we're looking to do this. So I'm going to try to squeeze this in here. So we're going to do two things. We're going to start with finding the sum. Right, so for us finding the sum, that is us doing the area under the curve from -2 to 2. And our equation is x squared plus 1. And so I'm going to do the antiderivative, which is going to add a power divided by the power x cubed divided by 3 plus x. And we're going from -2 to 2. So here I'm going to take 2 and cube it. So I'm looking at getting an 8. Up 2 cubed minus 3 plus 2. And then minus a -2 cubed divided by 3 plus a -2. All right, so those are my areas. Let's see what I get out of this. I'm getting an 8/3. 8/3 plus 2. And then minus a -8/3 minus 2. So we're looking at 8/3 plus 2 plus 8/3 plus 2. So that is 16/3. And this is going to be a 4, but if I make that a 4 over a 1, and I get a common denominator to combine with this one, I'm looking at a 12/3, which my sum then is going to be 28/3. All right, so that is our sum, but I want to find the average. And so if I'm going to do the average, I'm going to now take this number. So we want a sum. There's our sum. So 28/3. And I want to divide it by kind of the spread between them. So from a -2 to a +2, that distance, if I want to do the math, I'm going to take bigger number minus the smaller number. And so I'm really taking 28/3 and dividing it by over 4. Right, so, and then I will, instead of dividing by 4, do the math here. I'm going to do a 28/3. Instead of dividing by 4, I'm going to multiply by its reciprocal. So I'll multiply by a 4th. Then I can simplify. That'll be a 7. That'll be a 2. So I'm looking at 7. Dividing a 4 into both. So that'll become a 1. So I'm looking at an average area of 7/3. All right, so that was my average area on the first one. So let's see if we do another one. So if I do this one, same kind of math, I am finding the sum. The sum is going to be us going from 1 to e, 1 over x dx. Should have had a dx here. Right, and then I do the antiderivative of this. So this is going to be 1 over x, which is coming from a natural log, sort of the natural log of the absolute value of x from 1 to e. So we're going to have the natural log of e minus the natural log of 1. Natural log of e is 1. The natural log of 1 is 0. So we're getting a total area of 1, which also represents our sum. And so then if we're doing an average on that, our average is going to be our sum divided by kind of the gap between them. So our sum is 1. divided by E minus 1, and that would represent our average, whatever decimal value that is. And then we'll do one last. We'll do a trig version. So on this one, same kind of thing. We're going from negative pi to pi, or negative pi over 2 to pi. So we're going to be doing the sum, which is going to be integral of negative pi over 2 to pi over 2 of cosine of x dx. And antiderivative of cosine. I kind of forget where I'm at in my path here. So I know sine goes to cosine, and I'm taking cosine and moving it, doing the antiderivative. So if I do the derivative of sine, I get cosine. If I do the antiderivative, I'm going to get back to sine. So the antiderivative of cosine is sine, and then I'm going to go sine of x from negative pi over 2 to pi over 2. So I have sine pi over 2 minus sine of negative pi over 2. So value-wise for that, I'm going to look at a graph on this one. So sine curve looks like that. That is pi over 2. So I know that value is a 1 minus, and then if I go backwards on this pattern, that's my negative pi over 2. So if my negative pi over 2 is going to be a negative 1. So my area under that curve is going to be a 2. So that's my sum. And if I want to find the average over that period, over that span, I'm going to take my sum divided by the difference between that. So I'm going to take a pi over 2 minus a negative pi over 2. So I have 2 over pi over 2 plus pi over 2, which is, so a half plus a half is 1. So it's just going to be pi over 2. So that is going to be my average. All right, so that was us doing an average. Here's our formula, but I can think of it kind of more of something that I've seen for years and years and years, is I'm literally just doing an average. I need a sum divided by some sort of a value between it, and that value is kind of how many values you have. That is going to be kind of the difference, the distance between these two values. So we're going to do our antiderivative, find an area, which represents our sum, and then we're going to divide it by the distance between our two bounds.